Okay. Actually, I was trying to I don't know if everyone received the agenda I sent out last night. Today's agenda is supposed to be programmable SAI, which this is a little bit forward-looking proposal on how to add or how to enable SAI to be more flexible, have the programmability. The data telemetry got moved to next week due to a few companies which cannot attend today, but they would like to participate in the discussing of data telemetry. However, I could not find Matty online now. Gohan, while waiting, I'm reaching out to him. Do you have any any pull requests or anything to discuss? Yeah, well, I'm reaching out to him. Okay. Okay, Gohan pinged me on Skype that his GoToMeeting crashed, has to rejoin.
I see him on now. He's unmuted.
Yeah, he rejoined. Hi, Mike. Can you unmute him? He said he cannot unmute himself.
He is unmuted, so he should be able to talk. And it shows him as connected to audio as well.
Okay. Seems like audio still doesn't work. So while waiting for Gohan, I wanted to ask the community if you have any thoughts about the next proposal that you would like to bring into the community, or pull requests or changes. In the for now to the end of the year, we have data telemetry by Barefoot, which will be have another iteration next week. The BFD proposal by Dell, which will be postponed either to the end of November or the early December. And this like a SAI programmability talk. Anything else you have in mind, so that we can have a look at that.
So one thing for the community to think about is how does SAI want to pass capabilities to the upper layer? what should be the framework when either when we initialize or if it's dynamic capabilities to pass to the upper layer.
Hello?
Yes.
Can you
Go
hear
ahead.
me?
We can hear you. Yeah, we can hear
Oh,
you.
okay. Yeah, I joined from the phone. Yeah. Yeah. So so can we find the Thai and Matty?
No, I could not. I could not reach both of them. Yeah. Meanwhile, we are starting the discussing by Nikos about how do we add capability to the SAI to query the capability of the chip.
Okay. And then go ahead. Yeah.
Yeah, Nikos, do you want to go ahead?
No, I think, I mean, I have certain things in mind, but I think maybe we should at least have a session, perhaps, to brainstorm how the different SAI implementers would like to achieve this. I don't. I mean, I can have a base proposal for some other meeting, but I mean, I don't have something to present right now. But I think it's a gap in the SAI that we would want to address sooner rather than later. And you know, the capabilities fall, in my opinion, into two groups, right? One is static, and the other one is dynamic. The static ones are the ones that, well, usually won't change. And it could be related to the chip, to the platform as a whole, to the what's it called? To the ports. And it could be dynamic. You can think of the case where SAI is running on a platform that is not a pizza box, but it's a chassis, and you can dynamically insert either RPs or interfaces. So there has to be a mechanism there to notify of those new capabilities, whether they are added or removed. Clearly, we don't have to go with the dynamic approach right from the start, but I think at least there needs to be two aspects of it. Functionality. One is to actually have the ability to register those capabilities with the system, and to be the ability to query them, and the ability to subscribe to any changes to those capabilities. That would be a minimum basis for a discussion. And then we can break down the capabilities into categories and see what should be the SAI APIs for accessing and querying them, and what would be the right abstracted data structures that need to exist so that they map correctly from to the upper layer, from ASIC to ASIC. You can think of this example as, okay, ASIC A supports I don't know, counters, a specific set of counters, while a different ASIC supports a slightly different set. But we still need to present the same information if they're there, or present an abstracted view, or present even a zero, that's okay, and present a unified set of counters to the upper layer, which should not know about the intricacies of its ASIC or its platform.
Hey, Nikos, this is Zubin from KVM. By designing two different objects and their granularity of the attributes within objects, or you're specifically referring to scaling and the table scale as well as counter scale and other things?
I'm sorry, can you repeat, because I missed, at least on my end, there was distortion on your voice initially when you started talking.
Yeah, sorry, Zubin, your voice comes still very distorted.
I mean, this is something that I feel that we would have to address, or at least tackle fairly soon as a community. Otherwise, it's going to prevent upper layers to implement features, or force them to do platform specific, or to introduce platform specific behavior if they want a feature, which is, it's something that they won't be able to avoid if that functionality is not provided. But it's also not the right thing for them to do. And I think that is, hopefully everybody agrees that is hopefully falls into the domain experiences and ownership of SAI. So, what do you guys think?
So, Nikos, I'm not sure that I understand exactly what you are suggesting. By the way, it's Mike Lazar from Dell.
Okay.
So, suggesting that the SAI implements extra functionality on top of, so sort of complements the NPU functionality to have uniform view at the API level. So for instance, like the examples with counters is relatively easy. If the counters are not present, we can return 0. But there are other things. So let's say BFD, for instance.
Sure.
Some NPUs, they support BFD in the ASIC, but some don't. Do you suggest that the SAI should actually implement BFD in software?
No. I'm suggesting that you need to give me an indication whether, in this specific case for BFD, do you actually support it? And I need to know at initialization. And why do I need to know that? Because if you don't give me that indication, maybe on my implementation, in order to turn BFD, clearly I have to drive it through a CLI. Well, if I don't have a software implementation of it, that CLI should not exist. For example, I'm giving you an example of how I could actually use that capability, whether you can support it or not, and say, you know what, take away the CLI, because the platform that you're on cannot actually support it. Now, clearly, you could come back and say, as I said, this is just an example, because you can come back and say, well, you can make that determination at compile time.
That's not what we are actually. Okay, so there are two things actually in the SAI that provide at least partial functionality in the area. So for things like BFD, which is supported by a SAI module or object, whatever we want to call it, as long as we query that API and it returns null, we know that that feature is not supported. So that's high-level feature granularity. The other one is attribute granularity, which is, do I support on this object, do I support this attribute? So that's where maybe we need to provide an extra function to query the attributes that are supported. Now, the other thing, however, is that regardless how we do it, there's something in the software which says, you know, when I'm so there are two things. You mentioned compile time, which we definitely want to avoid, which is I will have an if-def in my code. If I'm running on this platform, use BFD, which definitely at Dell, for instance, we don't even accept these if-defs. So our code has no if-defs. And if you, by the way, if you look at the...
It's true, it's true. I've just brought it up as an example as to how somebody could argue that, hey, you know what, I don't see that as a capability. You can examine it at compile time in the absence of that API. Perhaps BFD was not the most appropriate example, but think of the case where you actually insert. If we were to run on a chassis and you insert a new RP or you insert a new line guard, you need to get dynamically those capabilities without restarting the system.
Yes, but that's something which is present in a configuration file. So, or in
no. Dynamically, right? What configuration file?
Well, no. But that particular RP has actually a configuration file, or a, sorry, I shouldn't call it configuration file, an EEPROM or a characteristics file which says this, you know, this card supports BFD or this card supports this set of features or not, and based on that, I'm going to adapt my software, right? That's the way it happens. Or that's the way I would at least implement that software. Now, if we talk about the SAI, like the SAI API, what we can have the same type of querying capabilities. We say, you know, this SAI supports these features. But in the SAI case, what I'm trying to say is there are two categories. There's the first category, which is object. And I use BFD as an example. It could be MPLS, it could be anything else. It's a very large object. And we can say, well, this SAI does not support, or this NPU really does not support it. The other one, the other category is related to attributes. So I do support BFD or I do support MPLS, but I do not support this particular set of attributes. And with attributes, I could also have a choice of saying, going to the counter, like the examples with counters, I could say, well, although I do not support these counters, I'm always going to return 0. So I could actually claim that I support those counters, but they are always zeros. In other, I could say, well, it's a stupid example, but let's assume that, you know, I have the port operational status. For a particular NPU, it's always up. So those are the sort of two categories, and for the attributes, there are two subcategories: supported or partially supported or supported with default values. I do not see anything else.
Okay, so let me bring then the difficult example. Label stacking. How many labels does the hardware support to stack at any point in time? This is a capability that the software needs to take into account. For example, when I'm downloading to you a prefix with labels. If I present to you a prefix with labels that have 3 labels plus the layer 2 adjacency, then you won't be able to do it. However, if I download to you a prefix with 2 labels and the other label I have incorporated in the L2 adjacency, for which you do have space to blindly slap on, then you can properly work.
Okay, so is it behavior or is it
both
sizing? No, but well, so that's behavior essentially. So I'm supporting for MPLS, I'm supporting this behavior or another, which becomes really tricky, because now what we are saying, we have the pipeline model that we were discussing before, and what we are saying is, well, in these particular areas, my behaviors can be behavior A or behavior B, right?
Yeah.
That's what we are saying.
Yeah.
And that becomes really tricky.
Yes, of course.
Okay.
But I feel that it is the owner of those objects to represent them in such a way so that the relationship between those objects is reflected correctly for you so that you can actually process them and program the ASIC. So if I know your capabilities, or so to speak, your ability to behave one way and not another, then I can make a decision and say, oh, you know what? If that capability is the hardware, I cannot impose 3 labels at any point in time, but only 2. Then I need to present to you 4 objects: the prefix, to speak of it simplistically, the prefix, the 2 labels plus an adjacency, or a layer 2 rewrite, however you want to call it. And that layer 2 rewrite may incorporate the Ethernet header plus another label for which you have space. That would be a more appropriate example.
Okay, but you know, when we go to these behavior models, we really like, how many can we have? Can we, you know, for MPLS, can we have 3 behavior types? Can we have 20 behavior types? The only problem is we cannot, or we could, but I don't think it's realistic to have an arbitrary number of behaviors, because then the entire site fragments. So we would have to pick 2 or 3 and say these are the behaviors, and then my SAI would say I'm supporting behavior A, or maybe I'm supporting both. I mean, you know, maybe there are certain, you can program something and say I'm supporting both behaviors. But again, it becomes relatively complicated to handle this type of stuff. And it's not just for the SAI. Actually, I'm less concerned about the SAI as I'm concerned for the layers above. But anyway, it's a good discussion to have. I mean, I'm not saying we should stop it.
The thing is, how would you handle such cases?
No, I don't know. I'm just saying that it can very well be. I mean, you know, all that I'm saying is I think it's relatively difficult to do it. However, I would actually argue for having, you know, having the SAI basically saying I'm handling this, and then the upper layer will have to, the host adapter will have to implement maybe a separate module. It depends how different the 2 behaviors are. Like if I think of object-oriented programming, I could say, well, if they are not that much different, I'll have, you know, the superclass, the parent class, and then I'll have 2 slightly different implementation in the children classes, for instance. If they are entirely different, then I'd have to have instantiate a completely different class, maybe. I don't know. I mean, I haven't, it's just something that, you know, I make it on the fly right now.
Yeah, that's fine. That's fine.
But again, the problem is that I really don't think that we want to have too many such behaviors. And I would also argue that they should really be the exception rather than, well, something that doesn't occur too frequently. And if it does occur, you know, for certain, so let me back off a little bit. I think that we did a good job until now to define what I call the core behavior of the SAI, and I think that that's what's valuable. I think, and we can have the discussion on how to deal with, you know, this type of exceptions. I do prefer them to call them SAI extensions or experimental features rather than say, oh, we want to push all this into, let's call it the SAI mainstream or core behavior. That would be, just off the top of my head, I haven't given to it too much thought, that would be my preference. Because if we formalize this, I think that formalizing it will be complicated. My first, you know, objection or no. The second one is I think that it will find it complicated to implement in the SAI, and we'll put lots of, we'll sort of encourage the host adapter implementation to go in a way where, personally, I don't think it should go. I think that, we basically have this type of stuff defined somewhere outside the SAI. So the SAI, again, can say, well, I have this extension, and then the host adapter deals with it. But again, nothing really embedded in the core of the SAI. So I don't know whether it makes, how much sense it makes, but anyway.
So are you saying that, for example, in the case that I mentioned, with the labels, we still provide the SAI with the objects that we define at the upper layer, and then it's up to the SAI implementation to transform those objects and program the hardware?
Well, the API should have all options. And my take on it is there should be some configuration that's only known by the host adapter. And it will say, if I'm running on this platform, which implicitly means for me as a platform designer, I'm using this particular NPU, I'm going to have this behavior. And if I'm running on this other NPU, I'm going to have some other behavior. But again, for me, I have a setup file which says I'm running on this platform or another platform. And it's up to me as the implementer of the host adapter to decide what that behavior should be and what I do in the two cases.
Okay, so if I understand correctly, you're saying that you don't need to expose those capability or functionality to the upper layer, but you're saying, well, the upper layer should just use the API, and what happens whether I stack the labels or whether I incorporate one of the labels into the rewrite, the layer 2 rewrite, it should be up to the SAI implementation before it goes and says, oh, okay, well, I need to program my ASIC.
So the only thing that the SAI will need to do is to see if to reject a request if it cannot satisfy it. If it cannot program the ASIC in a certain way, the SAI should say, sorry, I can't do it.
I don't have to, but that's the thing. You're saying you cannot program the ASIC, but I can still make it work. That's the example that I'm bringing up, which says, if your rewrite is X bytes and you can handle it, all you need to do is consider it as a rewrite. What it is, you don't care. I can just put the other label there, and you would still work by imposing 2 labels, which is your capability, but imposing 3 is not.
Okay, so if the SAI can make it work, that's perfectly fine. It doesn't need to tell anything to the host adapter.
No, but that's the thing. Now we would not have to expose into the SAI implementation not just objects, but what these objects semantically mean, not what they are. You'll definitely need to know that this is a label, and this is a label stack. But you will need to have to understand that you can actually do that manipulation, and it can get more complex if you start involving load balances in the middle for the cases where the prefix is recursive or BGP, because you can have double load balancing objects, one for the gateway, and plus the labels, of course, for the VPN case, and then another load balancing object for the immediate next hop of the gateway, plus the IGP label. And if we take the case of inter-AS cases, then you can easily see that you need to have knowledge as to what those objects are at SAI. So the question becomes, do you want to take on that responsibility? For me, it makes it easier. If I sit at the upper layer, it's actually perfect. I just pass on the objects to you, I don't care. But just don't come back to me and say, not you. I'm talking to the ASIC. Just don't come back to me and say, you can't support this. If you want to fix it inside. And I'm perfectly fine with that approach. In which case, the upper layers don't need to know any of what the ASIC can actually support, and it makes my life easier.
Well, but okay, so probably I didn't entirely follow. So given that we already have an API with attributes, I'm assuming that the size supports those attributes. Right now, you are saying, well, there's behavior, and when you say there's behavior, and that's it's let's say let me take maybe a simpler example so that I can understand it better. So let's say that I tell the SAI to build a frame, like I don't know, an Ethernet frame. And let's say that I want to have Q in Q, like VLAN in VLAN. That's somewhat similar to labels in my mind. So if I push two VLANs and the SAI does not support it, my take on it would be the SAI should just reject it. So, and again, it's an artificial example. So there should not be, I mean, there is a behavior there. So one NPU may support it, the other one does not. So the one that does not should say, sorry, can't do it. So it can't really silently fail. But then the host adapter is supposed to know that it can't execute Q in Q on a particular NPU.
The problem is that I lose this functionality while I can actually make it work. Your NPU, not yours, sorry. I mean, that NPU cannot do it. Fine. But if I can present the objects in a different way, I can make it work for the NPU.
Well, so in this case, it depends, how do I make it work? Do I write software to make it work? I mean, how much software do I need to write? So again, if the software that I need to write in the SAI is relatively simple, it uses the functionality of the NPU to slightly tweak, say, an Ethernet frame or an MPLS frame or stack, then I think it's fine. If it uses software to implement a feature entirely, like the case for BFD, I think it's not fine. I think we should avoid this type of implementation in the SAI. So it's always a gray area. There's no, I don't think it's a black and white answer or situation. It's based on, and it's also based on how you prefer as a SAI implementer, how you want to do it. Like I could actually, if I want to do it in the SAI, I could choose to implement BFD in software. It should not be done, but if I want to do it, it's up to the company, the person who implements a SAI to decide what to do really. All we can do is make recommendations.
But that's the thing. Let's say I already have an implementation of BFD software. Now I get hardware support.
Mm-hmm.
Well, I will get it from some vendors, but I won't necessarily get it from all the vendors at the same time. The SAI needs to give me the capability that says, yep, not only the API is there, but the API won't do anything. Or the API may not be implementing, I don't know, the C bit properly. So how do I signal that to the upper layer to make the right decision, whatever that right decision is? As I said, I'm mentioning the case of the C bit in BFD, which is more granular behavior inside BFD. So, yeah, go ahead.
So what I'm saying is, for coarse behavior at a very, at an object level, it's easy. You just say you don't support this object and off you go, or you support this object. So that's easy. For granular behavior, my take on it, it should be more of a judgment call of the implementer of the SAI. So if it can simulate, call it simulate that behavior in software, then it can be, it could be done. But again,
that's different. So in the specific case that I picked, the CBIT actually gives you an indication whether the forwarding plane shares fate with the control plane. So if you tell me you can't support it, and when I go down, we lose that BFD capability, then BGP needs to react differently. So it's not just an implementation that you can say, oh, I can simulate it or not. I really need to know what that capability is so that the upper layer protocol can properly react to this.
Okay, so then that's important. So then it's important. So then I agree with you. So in this particular case, we should probably have something in the SAI which says I support this capability or I don't, and that's perfectly fine. Now the other thing is we did not have. I mean, I'll definitely have to sync up with my colleagues on this type of stuff because it's a very. I mean, it's a very good, to me, it's a very good initial discussion, but we'll really have to, you know, I don't think we can decide anything right now. And
brainstorming.
Yeah, so I do thank you for, you know, for mentioning all this type of stuff because, you know, there are certain things that, well, I frankly, I didn't think of them until, well, or I thought of it in some other ways. So that's fine. So let's keep going on this. So that's good. So okay. So we need capabilities, and definitely we need. I mean, there are other areas which are again simpler. How many ports do I have? Like, you know, we definitely need this type of information.
Or can I even break those ports? Can I do breakout?
Yeah, exactly. So where do I? And actually the interesting part is where do I want to keep that information? Because really that information needs to be there. Like on my platform somewhere, I need to have that information. So the question is, do I keep it in the SAI, and do I have a SAI API which actually returns all, you know, it returns all those type of information?
Yes.
For each object, I'll have some sort of I set up file configuration. I keep calling it configuration file, but capabilities file.
I think.
Yeah, sorry. Go ahead.
Yeah, I think this is you know, a good discussion. Just you know, this is probably some bigger topics. So just want to know that if any volunteers want to look at this problem and then make some proposals on this one?
So Gohan, I think we are like Adele. We are definitely interested in this type of stuff. It will take us a while to finalize something, but well, a part of it is because we are just at the end of a release and lots of people are busy. But it depends when do we want to have you know, a proposal, and definitely we can be in touch with all our partners who are, you know, interested in this type of stuff, and we'll figure something out. So with Nikos, and you know,
I don't think anybody's in a hurry. I just put it out there personally, and I didn't have a set deadline in my mind, Gohan. So it's up to you to kind of like say, okay, maybe we should have a proposal in the next, I don't know, 6 months or something, or in 2018, something like that.
Yeah, like I think you know, I think we have some as we use more features, I think there are some you know, hardware difference, capability difference in different size. So I think we're starting to see some problems on our side, on the Sonic side. So yeah, I agree with Nikos. You know, we're not in a hurry, but I think it would be nice to have this kind of proposal in like next release, something, or you know, early next year or mid next year, something like that.
Yeah. Because it also plays into the into each ASIC vendor's hands and say, okay, I want to take advantage of this capability of my ASIC, which nobody else has. Well, how do I present this to the software above if I need to do that? I can't, right? Another thing that I wanted to discuss, since we have many, I think many, or at least 2 or 3 ASIC vendors in this call, is I want an API that can do 2 things, or at least maybe a different API. Given the 5-tuple, I want either with an API or some program that I can actually simulate exactly what the ASIC is going to do, have an answer as to where this flow is going to hash. And I want also the ability to do this not only for the interfaces that are currently up, but also simulate if I take away one of those interfaces. So for example, I do 4-way CMP. I give you a 5-tuple, and you tell me it's going to go out bucket number 1 out of the 4 buckets. Now, if I take away one of the interfaces, maybe that bucket will change. I need that information. The requirement is quite big. Once I have that information, I can map anything I want in my network, incoming or outgoing. I don't even have to use any of the NetFlow, Everflow, StarFlow, whatever you want to call it, functionality. And I can programmatically query my servers or my incoming connections and say, okay, please tell me your flows. I know what my next hop is, or what my next hops are. I'll go to them and I'll figure out, and I will have a complete map of my network along with my flows, and I can make intelligent decisions, not only for provisioning, but also for mitigating failures. Let's say 2 failures go down, or I see 2 things flapping continuously, or maybe I have intelligent software that actually says, you know what, those optics or the QSFP modules that you have deployed, we have information that they say, I'm giving a hypothetical example that's far-fetched into the future. It can tell, you know what, this module is going to fail in 3 months. And we're nearing to that period. So this is how your traffic will be effective if that module fails. I can mitigate it statically. I can do nothing. Or I can say, you know what, I have intelligence to actually direct the flows from now and use different buckets, or use a controller to influence where the flows are going to go. So those sort of things. A more intelligent network, and I want to have that API or that program or whatever the vendors want to give me. That's a huge ability for me and a huge selling point.
Okay, yeah.
And I don't know how, I mean, the vendors, ASIC vendors, or even OEMs need to start providing, if they don't have it, that capability, because that's where we're going. I think that's where the world will be going. There is no way that currently I can statically define and say, oh, okay, where is my flow going? You look at something and say, I have no idea. You go to the next hop and you say, okay, where is this going? I don't know. We're doing 4-way CMP, or 8-way CMP, or 16-way CMP. No clue. Figure it out with your NetFlow sampling. Nah, not really. I don't want to do that.
Is there something related to the INT, you know, in-band telemetry, those kind of things?
Yes, yes. It is part of the broader, bigger picture of telemetry, as far as I'm concerned. I don't know who's working on the telemetry proposal or what do they have in mind, but when that proposal comes on the table, I want us to be able to say, yes, we all need the telemetry or whatever it's being on the table, but I also want this.
Yeah, I think there's Barefoot. They have int proposals. I think also I think the Broadcom next week they're going to also talk about their idea about these telemetries. Yeah.
So I mean, with all due respect, all the vendors are looking after a broader customer base or their market and whatnot, what they need to satisfy, proliferate their business. So most likely, and I don't know because I haven't looked at any proposal. I haven't seen anything. I don't think anybody can address this issue programmatically. Currently, most of them enable some sort of flow sampling, and they try to figure that out. And what I'm actually saying, I think the distinction is I can not only programmatically do this, but I can have an answer by simulating this, if you want to call that, and say, okay, I took away 2 links, what happens now? The flow sampling won't tell me that. So I need to have a way to get the programmatic answer without knowing the algorithm from the SAI, the ASIC. I need some way, right? I think you understand why the sampling won't give me such an answer, right?
Yeah.
So today I can go to the server, I can query the kernel and say, please tell me about all your flows, and it will do that. I can go to the next hop, query with this API. I can even visualize all this. I'm almost halfway there. So I just need those APIs to be able to just literally turn on the lights in the network. And then, you know, upstream it, open source it, whatever. And then everybody can just say, okay, let's do some clever things. Let's figure out failure scenarios. Let's run some scenarios that tell me what will get impacted if I fail out this node. How will my capacity change? Do I need to provision something else? And so on. So anyway, that's what I wanted to point out.
Yeah, so yeah, I think for the first one, it's probably, you know, something that it may be more practical for the ASIC vendors to do it, but I'm not sure. So maybe I think you know, Nikos, if you and write something, I think send out, you know, either to the main list or kind of query APIs to do what you know, 5 tuples. You can know which exactly output is going to be. You know, that might be, then we can see if the ASIC vendor can support that or not. For the other one, I'm not sure. It depends on what kind of fidelity their simulation. You know, it kind of, you want some simulations from their SDKs, and usually it's difficult to do, you know, very high fidelity simulation because they have so many ASICs and they have different hash value, high seeds, if you know we need to software to take care of that, that's a lot of software to write.
Yeah,
right.
I agree. I agree. I mean, I just put it out there. I put out there my current state, which is I got nothing, to where ultimately I want to be. Maybe today, as you said, yeah, that's a lot of software. We can't do this right now, but we could give you the first one. That would still be great.
Yeah. So.
Yeah, I can put a proposal or a request for a proposal or something that basically says, please implement this.
Yeah.
Because it can be part of the telemetry.
Yeah.
We do want to somehow extract that information off the box, and if it's implemented within SAI, for all my flows, I can say, please tell me how that hash is that's currently going through your box. I get the answer, I ship it off somewhere else.
Yeah, but maybe, you know, with their more advanced telemetry, they have some way to actually do the simulation in the hardware. Yeah, so I think, you know, with current generation of the ASIC, I think they have to do a lot of simulation of the software. But maybe in their future ASIC planning, they can do something in the
because the hardware. Yeah, I mean, I agree with you. Totally agree. Maybe they do have a way of doing this. Currently, from what I've seen, most of them rely on some form of flow sampling. Or they rely on some secondary CPU inside the ASIC or a core inside the ASIC, and they use that and they say, okay, let me do XYZ, and I'll give you a sample of it. Well, yeah, you know, it goes half the distance, not all the way as to, yeah, no, I really want grammatically to say, tell me where is this gonna hash? Because you have the flow. If you don't have more flow sampling, because there's no traffic right now, you won't get any information. You have to rely on what you used to have. Well, maybe that's changed. I don't know. You know, unless you query, the flow sampling won't give you anything because there's no traffic flowing. You understand what I'm saying, right?
Yeah, I understand. Yeah, yes.
Okay.
I think yeah. So let's I think the problem is clear. I think it's let's wait for some time to get the ASIC vendors to get back on this one. Yeah. Yeah. So I think I really apologize for currently. I think the Manloc's unable to join today's meeting, so we'll have to defer their talk to the programmable side into you know the week after next. We'll iron out the schedule and then get back to you. Yeah, just before let everybody goes, I think there is a proposal. I think it's a fix for the ACO critical resource monitoring proposal, because mainly I think we found some previously inefficiency of the API designs, and also there are some issues on that. So that's a pull request 731. If someone can look at offline, that would be great. I think on the high level, I think when we try to currently when we try to create ACO tables, ACO group tables, we need to specify the binding point and the stage. So I think when we try to query the number of ACO tables we can create, we should also specify the same parameters in order to get accurate estimation of the available resources for the ACO table. So that's we changed that. Previously when we create the echo table and group numbers available, we do not specify those two parameters.
So
I think that's one.
I don't want to open a discussion to hold everyone in the call, but I'm curious to understand why, when you create a table, you need a binding point. The table should be just a table. What am I missing here?
Yeah, because I think it's facilitated the hardware to, because some hardware they are trying to pre-allocate the resources because when they're trying to create table, you need to give the match field that you want to match, right? But in some hardware, not all the match field is available for all the different binding points. So therefore, they need to, during the create table, you give a hint on what the binding point you are going to use. Then they can decide that whether those match fields are available on that binding point. So they can return you failure early, because otherwise you will get failure only when you actually trying to bind it, and that someone they want to do the table instantiations before before you bind. They want to do it earlier to maintain less software resources.
So help me understand why should how would they know, the user that actually puts an ACL there, because I think that pushes a requirement up the stack or up the layers to basically say, you got to give me a table where you're going to put your ACLs. Not only that, but you're going to tell me how you go planning on binding that. Is my interpretation accurate?
Yeah, so the user can give a list of binding points that they potentially want to bind for this one. Yeah.
What if I don't know and I say, well, star, everything?
Yeah, you can say star. Yeah, you can say star.
Oh, okay.
Yeah.
Okay. But I still need to arrange my ACLs into tables, right? Is that a reasonable requirement, you think?
Sure.
Right, so I said that from what I understand, I still need to arrange my ACLs into tables. Is that a reasonable requirement to push northbound? I mean, today it's this hardware, tomorrow is something else. Why would I, as a user, care? An ACL is an ACL. Here's an ACL. You may have a set, you may have a match, you may have an action, maybe you won't. And then eventually I'll tell you if I want to bind it to a port, a physical port, to an VLAN, to a tunnel, to whatever. But I know nothing about tables, right? Why should I? Just ask you. Is that reasonable to push northbound? The knowledge of tables?
Yeah, you can specify a wildcard. If you don't want to do it, that just require more hardware resources, because then they need to pre-allocate all kinds of binding points in order for this when they try to create this table.
Okay.
It's just optimization that
Okay. So I can just have one table with the wildcard and put all my ACLs there.
Yeah.
Then I can specify. Can I specify on the ACL to which interface it can be applied to, or do I have to go to the table and say, no, it's not per ACL rule, it's per table?
Yeah, I think you have match field to do it on the per ACL entry basis.
Oh, I can do it per ACL. If I can do it on a per ACL basis, I'm fine. That's fine.
Yeah. You just need to add those match fields to the ACL table entries. Yeah, but you also do the binding point. Okay. Yeah. So you know, that's one thing, and other things is that when we created the number of interests in the table, we moved the available resources to the ACO table, and the ACO table, the available counter and interest to the ACO table. Yeah, so that's the two changes for the request. Yeah, you can take a look at that, and you give us a feedback on these changes of it. Yeah. I think that's all I have. Yeah. Yeah, thanks. Yeah, so.
Bye.
Bye. Bye. Yeah, so talk to you next week.